3.2 Triangle Congruence. In this lesson, you will be introduced to triangle congruence theorems. The first theorem, side, 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 or SSS. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. If AB is congruent to DE and BC is congruent to FE and AC is congruent to DF, then triangle ABC is congruent to triangle DEF by SSS, or side-side-side theorem. Another theorem is side angle side, or SAS. If two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then the two triangles are congruent. AB is congruent to DE. Angle B is congruent to angle E. And side BC is congruent to side EF. Then triangle ABC is congruent to triangle DEF by SAS. Notice that the angle is in between the two sides for each triangle. Next we have angle side angle, or ASA. If two triangles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So in this example, we have angle A is congruent to angle D. Side AB is congruent to side DE. And angle B is congruent to angle E. Notice that the side is in between the two angles. Then triangle ABC is congruent to triangle DEF by ASA. Notice the S, which stands for side, is between the two A, or angles. Next is angle angle side, or AAS. If two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. So in this image, notice we have two angles, but the side is not between the angles. So we have angle A is congruent to angle D. Angle B is congruent to angle E. And then side BC. Then triangle ABC is congruent to triangle DEF by AAS. Finally, we have hypotenuse leg, or HL. If the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. The hypotenuse is the longest side of a right triangle. It's always opposite of the 90-degree angle. The two remaining sides are called legs. If BC is congruent to EF and side AB is congruent to side DE, then triangle ABC is congruent to triangle DEF by HL. Let's try some examples. Number 1. In this image, we have an angle, a side, and then an angle. Angle, side, angle for the left triangle. Angle, side, angle for the right triangle. This is ASA, angle, side, angle. Please pause the video and attempt number 2. Hopefully you notice that this side is congruent to this side because they have single tick marks. This side is congruent to this side because there are two tick marks. And then this side is congruent to itself. It's the same side. So we have three sides on each triangle. This is SSS. Go ahead and try number 3 and number 4. Hopefully in number 3 you notice that we have 2 angles and a side, and that side is not between the 2 angles. So this should be angle, angle, side. Angle, angle, side. AAS. Number 4, because we have right triangles, this long side is the hypotenuse, and these shorter sides are the legs. So HL. Let's look at number 5. As we saw in previous examples, the tick marks show us the congruency. We have a 1 tick mark and a 1 tick mark. We have a 2 tick mark side and another 2 tick mark side. But it's not enough information yet. See if you can find any other information using properties you've learned in previous units. Hopefully you notice that you have a pair of vertical angles here and here. So here we have 2 sides and a non-included angle. However, that's not one of our theorems. SSA does not work. There's not enough information to answer this question. We cannot tell if these triangles are congruent with the given information. In A. Number 6. From the diagram, we can see that these sides are congruent. And we can see that these angles are congruent. We also have arrows. This indicates these lines are parallel. Because they are parallel, this side here acts as a transversal, and we have corresponding angles. Corresponding angles are congruent. Angle, side, angle.